Hello, everyone, and welcome to our sessions on digital heritage inspection and survey, which are kindly funded by Historic England. This is a programme of 10 sessions for learners of different experiences and backgrounds to find out more about how digital models and digital twins are being used in the heritage sector. There's a WhatsApp group where the learners can co-mentor and share resources too. My name is Linda Jubb and I'm your host today. I'm a Chartered Building Surveyor and Fellow of the Royal Institution of Chartered Surveyors. Our practice, Jubb Clues, specialises in the survey and repair of historic buildings. My co-host today is Chris Jackson, and I'm going to ask him to introduce himself in a minute. He's the MD of Christians, the survey company, and you've already met his colleague, Kira, in sessions 1 and 2. Today, we're going to be covering three areas really around the interpretation of models. First of all, how to understand and interpret a range of digital twin models, and there'll be quite a lot on how we share them. We'll show how different kinds of data can interact, so it's not just the 3D model that we've been looking at. There's other kinds of data that you'll be able to use. And we'll just have a little touch again on accuracy, because that's something we've been building through all of these. So before I start to chat about viewers, I just wonder if, Chris, you've got a moment to pop your camera on and introduce yourself.
So I'm Chris from Christians. I've actually been demoted now. I'm not MD anymore. I gave that privilege to Thomas. Yeah, I'm going to hopefully flick through lots of live data sets, and I just encourage people to ask as many questions as possible and butt in where you need to. And yeah, I quite like it to be a bit fluid and everyone try and get what they need out of the presentation, really.
I do hope it goes that way today, Chris, because
Yeah.
people have been engaging more and more. This isn't a webinar. It's not where everybody's mics are off and we just shove information to them. People can
Yeah.
hand up, jump in, tell their stories, share their models. I really love that. So I don't know whether you want to start with a screen share and show us some of your models, or whether you would like me to just chat a little bit about how we share the models, because there's lots of different viewing platforms. And in the WhatsApp group this morning, Mark and I exchanged some details around Sketchfab, which is the platform that Tom Martin was using for the model that he made that we were showing in session 3 of Hampton Gate. And Mark has recently loaded up some of those wells in Clitheroe that he's done his own models for, and they look amazing. So Sketchfab is quite good. It's free if you want to put a few things on it. One of the reasons you would use these viewers is because it means that you can, first of all, share them with other people, and also it's just slightly less bandwidth on your own internal storage. It just gives you a little bit more capacity. Quite a lot of the models we've used with other providers, Chris, are provided through My 3D Cloud as well. Sketchfab, it's really good for your 3D models, the reality capture ones. And as I say, Tom was having to downsample what he put up there. You can't put up masses of stuff. You certainly can't do it for free. But it was a good enough model, and it suited us for the purposes we had. I mean, I'm just going to run his little video there. You know, it's not a geospatial professionals model. Let's just hasten to add that. Tom's an engineer, and this was done for a specific purpose because we were concerned about safety, and we needed some data before we actually even planned our approach to that particular monument. The ones that you get with the scanners, I don't know whether you use any of these, Chris, things like Leica, TrueView, they're very good for the point clouds and so on. And I would encourage everybody to just go and have a look at those websites and play with the models that are there, because you can see that they've got these hop round from the different angles. So they're starting to have that kind of user interface where you can engage with them. They're putting up different kinds of data. You know, you can see some thermal imaging data there. And they've got the usual facilities about being able to measure, which is so useful for the QSs who are here, who are having to do quantification and taking off. Faro WebShare, very similar. Again, you can see the jump round points on there, and going into the detail of it, it's got the measuring facility on it, and also you can extract that ortho imagery that we talked about in previous sessions. Oh, sorry, this is the cue for you to jump in, Chris, because we're going to talk a bit about Liverpool Cathedral. What platform did you use to share that?
So Liverpool Cathedral, the laser scan data is shared through the Faro WebShare system, and also you can download it on your own computer using the Trimble like laser scan share, and then the photogrammetry models are about 30 gigabytes. So we have that on our own web platform that people can log into on site, look at it on their iPad or their iPhone and comment and, zoom in and look at something that they can't see from the ground. But also the people tend to have the hard copy as well, because there's obviously, with the larger models, you'll find that you're kind of limited by the bandwidth on the internet. But yeah, obviously with Liverpool Cathedral as well, we've got the full Revit model as well, and that's shared through Autodesk's BIM 360, that then people can go in, take measurements, pull elevations off sections, whatever information they want really, and PDF plans. Everything is accessed through the Autodesk BIM 360 web application.
Are they putting a lot of specification detail into the back of that as well, design detail?
Yeah, and it's interesting because on the Revit model, we're starting to put data into it. So sensors on site, we're using it for airflow analysis, for heating. We've got historic plans from when it was constructed in the model as well. So that's quite good. And comparing them to what's actually been built is very interesting, for a different time, definitely. Yeah. So we have a Sketchfab account. We have a professional one that we pay for, and we have lots of samples on here, various different things. What you find is it tends to be lower resolution models.
So what we're seeing in the Sketchfab platform that you've loaded up on the cathedral there, I can just see Liverpool Cathedral. That isn't. Yeah. There's different copies of that model saved in different places. So you're saying you've got the Revit model, and the design team are using that with data sets behind it for design.
Yeah.
And you've got your Trimble one. Was it Trimble you said?
Yeah, exactly. Yeah. So it depends what you find with the survey industry at the moment is that everyone wants access to all the different bits of data. So the first thing you'll go is onto site and you'll put site control in using a total station and GPS to coordinate the site. And then you'll go and laser scan everything. And everyone wants access to the laser scan data, which would be your like a TrueView, Trimble, RealWorks View, Faro WebShare. There's a few others out. Yeah, that's just the point cloud, which will give you your 360 views and you can take measurements. And then obviously from the point cloud, you would bring that into the photogrammetry software, combine it with, I think, 100 and odd thousand images we took of Liverpool Anglican Cathedral. So obviously it's quite a big folder, very big project, sorry. And then we have different levels of quality of that. So you have the main quality, which is 0.25 mil resolution, not accuracy, resolution. So you can zoom in, and the architects sent us screenshots of where he's found dead flies on windows and things like that. And then
We're
depending,
literally into the corner of too much information there.
yeah, exactly. But then, not everyone needs access to that crazy level of detail. This is on here for the media team at the cathedral who are using it for I admit that person. They're using it for like fly throughs, showing people, trying to raise money for renovation works, new schemes. So they only need access to a very low resolution model. And then obviously, depending who's the engineer, the cathedral architects, they would have the highest detail. Then we have like a medium detail one as well, so it's accessible on site. So I don't know if you can see my cursor there. You might have the architect and a stonemason, and they want to look at this top window here about replacing it, so they can pull it up on their iPad or their iPhone, zoom in, take measurements, and say, that piece is 300 mil by 200 by 100. You can see where it's cracked there, and I think.
So I have a question, which is sort of to jump forward into accuracy and post-publishing corrections, because when you've got different versions of the same model existing in different channels for different audiences, I know that in a BIM team, you'll have regular sort of clash control meetings as you go through the design process, where people are saying, I was looking in the model and I want to run the ducting through here, but I can see that's hitting structure or something like that. What happens sort of at your level as the owner, if you like, and the publisher of these models to control the versions that are in these different channels?
So obviously we just have a document that goes out to the team, and we kind of control who has access to the models and what it's for. And it's very important that they understand what they can achieve with their model. So obviously the highest accuracy models will go out to the engineers, to the architects, people like the media teams and stuff. It's more about getting it to work nice and fluid online, and it's not about accuracies, although everything that we do send out is geo-referenced, and it is scaled and accurate. So they could, for instance, pull up and they'll be able to measure and say that's 15 centimeters, where the architect could turn around and measure on their model and say it's 15.6 centimeters. So it's just making sure everyone knows what they've got, really. But as surveyors, we always like to just deliver the accuracy that we can achieve and the precision that we can achieve. It makes us very nervous sometimes, because we might put a price in for something and someone will come back and say, if you don't do it quite as accurate, can we have a cheaper price? Where that's the world's worst thing to ask a surveyor, I think. It fills us with dread, because a surveyor should always be aiming to give the best detail, the best accuracy that they possibly can. That's my view anyway.
That's been a really big strong theme in these sessions here, is that, for instance, when we were looking at Tom Martin's model that you've just seen on Sketchfab, he's not a geospatial, and if you have got that sort of geospatial training, you can't do it any other way. There is no other standard, because that's the standard that you're held to, that you're insured for.
Correct.
And I'm very glad to see Eleanor Hazelhurst here today as well. Hello, Eleanor. Because next week we are going to talk a bit more about business case and procurement. And once or twice in the sessions it's come up about, but how does this work in practice? How do you choose the level of detail that you need? What's the big difference between something that's relatively easy to do, like Mark's done, for a very small structure, for a very early stage of a project where there's no funding and there's no expectations, compared to the point when Christians turn up and do it properly, because you don't want to do everything twice. And even once you have done it, like you say, you've got this version control. And I was going to just touch a little bit on copyright as well. Presumably, you hold the copyright for all of these models. So, in terms of communicating to surveyors, architects, anybody who's looking at these models, just as you would have done with the ordinary documentation of keeping document issue sheets and so on, and explaining to people you use it, but you check that you're on your current issue, you check in with us regularly. Is that something you've been able to do for all your models, or do you feel as though that's on the client?
Yeah, we have versions, but we issue a version document, but also, it might be LAC 2020 2025 V1, V2, V3, and we try and keep it as simple as possible, because it can just get very confusing. And what we try to do is just issue as little as possible. Like, we don't want to be issuing hundreds of different versions of models, because it can get a little confusing for people, and especially when decisions are being made. It makes a big difference. But it's interesting on the accuracies and things, and especially around anything to do with drones, anything to do with photogrammetry, but even now survey equipment. And people tend to know that I'm quite vocal about equipment sales people selling things that can do things that can't actually achieve what they're saying. A lot of people will say, "Oh, I'll get you a topographical survey, but I'll do it with a drone, and I'll get you 1 centimeter accuracy," which in the real world isn't achievable. It's hard to achieve that with proper land survey equipment like Total Station and GNSS, and knowing what you can and can't achieve is really important. And if it sounds a bit too good to be true, you need to be asking questions. Like we, for instance, we had a quote come through yesterday, and they wanted a drone topographical survey, which always fills me with dread, because, if we're doing that, for some jobs, it's perfectly fine. But if, we went back and said, well, what accuracy do you need? And they said, oh, we need it plus minus 20 mil. And but we were saying, but the grass, you've got brambles, grass and stuff. I said, we're probably looking at 250 mil accuracy there. But the price to do it and try and get it as good as possible and give you 250 mil that we'll guarantee, we can just do it the old-fashioned traditional way and give you exactly what you want, and it's actually the same price. So it's knowing when and what to use things for.
That's why I was going to ask you a bit more about the equipment, because I've been looking into the history of Leica, and obviously, when they made the innovation, the Cyrax, when they brought in the first laser scanners, part of the reason that they're providing these viewers and platforms is because they're pioneering. We don't all have the sort of software that can read a point cloud, so being able to share it through theirs means that they can, I assume, learn how people are using it, what the volume of traffic is on these different technologies, and therefore learn where to invest. Not all technologies succeed. Is this the one you did of? Is this Haslington?
No, this is the Shambles in York. So,
right, okay.
We've been working on this project, and obviously everyone knows the Shambles in York, and we've it's a bit of a funny one. We've actually been doing it for a media company who were looking at, instead of having hundreds of actors on site and having to close it down, we're looking at ways that we can document a site by laser scanning it, building a 3D model, and then bringing
green screen them into it.
Yeah, exactly. And it's really interesting to see. But what you can do is you can, I mean, this is laser scan data. This is in recap. So this kind of comes into when we start sharing in a minute. But
So recap is, sorry, where the model is
Autodesk.
built.
So
Okay.
Autodesk recap is like a point cloud viewer, really,
Right,
and
okay.
it's what we use to also do the end processing to get the point cloud into softwares like Revit and AutoCAD when we're doing the modeling. But a lot of people have Autodesk products, and recap tends to be with a lot of the products from Autodesk given for free. So it's actually a really simple, cheap way of clients getting the point clouds and being able to use them. And you can still do things like, you can change resolutions, you can change it to like different colors if you can't see.
But other than those geotags for those different locations that you're jumping between, which are in the
Yeah,
top right corner, has it got any other sort of geotag or backdata to it?
not no, not in here, not in here.
Right. Okay. So it's just the really basic. Yeah.
Yeah, it's really basic, but this is really a portal to bring it into other Autodesk softwares. But if you want to have a look at it, it's a great way. But something a bit more, this is the Trimble RealWorks version. So Trimble obviously are a supplier of laser scanners and total stations. There's we don't we use the Trimble version every now and again now, but actually we've migrated over to all Leica laser scanners and Leica software for point clouds. But yeah, you can. It works exactly the same. You've got a 360 view. You can move. You just click on one of these points and you can go and have a look around.
So those triangles, are those your
That's each scan location.
those
So
are scan locations?
yeah.
And,
So obviously
are your targets visible in there, or are they all deleted out?
they are, because of the nature of this building. We controlled this by actually using corners of brickwork that we put very
Okay.
small marks on, because we weren't allowed to put any stickers or anything on there. It would have had a traverse through with a total station beforehand. But yeah, so you can see here Winston Churchill. And this is the Trimble one is actually really good because it's a really nice viewer. You
really
can actually
crisp.
download. Yeah, you can download this on your own laptop as well, and you have. I can see that there. You've got different like sort of measurements you can do. So you can take a point and it'll give you the coordinates of that point.
How tall is Winston when he's sitting down? Then just tell me.
Let's have a look. So I've not used this one in a long time. So you can control it. So what if we go to the ground there? So can you see how I clicked on the top of his head and down here?
Yeah.
But instead of it giving me the measurement to the 2 points I've clicked, it's done it on a plane.
So it takes an ortho plane whenever
yeah,
you do
exactly.
that. Yeah, okay.
Yeah.
That's really useful, isn't it?
It's really a really good powerful tool. And what you can do in this as well is you can annotate and put images in and things and draw around things. So you can click there and put.
So where does that data that you've added in live? Because that's not come from the Trimble scanner. That's come from the user.
Yeah, sorry, can you repeat? I just broke up then.
I'm just trying to understand where the data lives. Does it live? It lives. You give it to Trimble and they store it in their viewer.
Yeah, so with this one here, because this is on your own computer, this would stay on your own computer.
Okay,
this
so
is this is for
okay.
Yeah, no, this one's not a cloud. Trimble don't do a cloud version of this actual product, but we do have cloud ones, and I think you mentioned Faro WebShare, and that is I would say that's probably one of the best laser scan sharing platforms there is, because you can do so much in it. We've got big national grid sites where they have, all information that everyone puts in it, and they can say, oh, I've inspected that on such a date, and they've got images mingled in with the data, and that's saved in the cloud. And so everyone, if someone goes on it 3 days later, they'll see where someone else's notes are and things. So that's quite a good one.
Yeah, the Faro Web Share is one we've used, and what we're finding, one of the purposes of these sessions is to give other people confidence about putting their own data onto it.
Yeah,
and actually sort of contributing to models that they don't own and storing, because I think the way we're all trained is it's like, oh, that's somebody else's data.
But see, we have that as well, where people are a bit, oh, I don't want to go on there and put a note on it, or I don't want to touch it, or I don't want to take that measurement and things. But you just need to be aware that anything can be reverted back to its original thing. We can step it back. We can go in the background and see all the changes, and you can't really, you won't be able to damage it. Just the best way to do is ask someone like ourselves just for access to a sample one that you can play around with, before you use your main your main project. There's enough data sets
really
out there.
Public ones. I'm going to come to this in a minute. That we can move on to. I'm going to just invite. There's something in the chat. Brahim, have you got your camera, your mic open, and you can ask your question, please? Because I can read it out for you, but if you're here, you might as well ask it yourself. Brahim, is he here? You might be. There
Yes, I'm here.
Hello.
You heard me?
Yeah, I can hear you.
Yep.
Hello, everyone. So my question is about the level of accuracy. So if I would like to do a survey, and after I will give this point cloud to a team for doing a beam, maybe.
Yep.
How can I measure? How can I define the level of accuracy? It's 20 mm or 40 mm or 50 mm, depends on what.
Yeah, I mean, it's I could do 2 hours of talking about accuracy and going into the ins and out of it. And what I would say is when you get instructed to do a project, you should ask for a specification of what the client wants. So, we get clients that say, oh, it needs to be 1 mil accurate, or 5 mil accurate, or 10 mil accurate. And there's so many things that can come into the project that changes that. You've got your GNSS, your GPS points for the initial setup, shooting in targets for your point cloud to geolocate it. Have you done a traverse, or have you just set up over 2 points and done, say, three points to locate your project, or do you have control points all around? The density of your scan.
Bring up this slide. I don't know whether it's showing for all of you. This is just a loop back to some of the previous work we've done for him, where this is from the guidance on geospatial projects for cultural heritage, which John Bedford, whom you would have met in one of the other sessions, he was one of the authors on this, has brought forward all of this information, and that's the same as in the RICS guidance note. So that gives you an idea of what kind of accuracy you can apply to different kinds of projects. But I think what Chris is saying is that which side of the desk are you on, Brahim? Are you client side asking for a level of detail, or are you surveyor side trying to understand what level of detail to supply?
Yes, I'm like a surveyor, not a client.
So those are I actually pulled these up because I was going to share these as well on the accuracy side. So there's some really good documents that are free to download. The two by Historic England are, as you can see there, and if you just jot down the names of those two documentations, you can download those as PDFs. But if you go on the Historic England website as well, there's lots of other documents on there that would be really good for you to download.
I'll share the reading list, Chris.
Yeah,
Ibrahim, I'll
yeah,
send out a hot link reading list for you.
yeah,
And we've got a downloadable pack which has got a lot of this in. There's actually also some webinars backing this up where Historic England have gone into the detail of how that specification was written, but I'm happy to go into it anytime. I think that the main thing to remember about accuracy is that it isn't just about the accuracy of the data that you collect and then the project at the end. It's also about error control in between, of making sure, for instance, like we spoke about today, that you're working from the same version, that you aren't working from a downsampled version, and that the downsampling hasn't stripped away some of the resolution and the detail that you're relying on if you're doing, say, condition surveying with it.
yeah.
And vice versa. I think the QSs here will say, obviously, there's got to be a real world check back, check measures and so on, just to make sure that things haven't diverged later on.
Yeah, I think we do lots of internal QAing of all our work, and we have very specific workflows. And you could give 10 people exactly the same laser scanner, total station GPS, and you will get 10 different results.
And we had a really interesting conversation, didn't we, also about what the actual machines themselves can deliver once you add in human error. You were talking about the tolerances on that.
Yeah. Like if you have a laser scanner and the beam is 1 mil wide at 10 meters, at 100 meters, it's going to be, I can't think off the top of my head, but say it could be 10 mil. So your accuracy isn't going to, the data at a further distance on a laser scanner isn't going to be as good as a close. But then you've got your cloud-to-cloud registration. If you're slightly off, you've got your error there. You slightly shoot off your targets, so there's a couple of mil error there. So there's it is a very difficult question, and it's almost 2 hours of another session really going through best practice for that. It's a good question, but a really difficult question to answer in.
I don't mind going back over it at any time, and we will touch on it again. So one of the other things that's also making sure the traverse is right. I've just seen Gordon popped up. He's offered some guidance, which is the RICS Earth Observation Aerial Surveys. Is that useful for you, Gordon, when you're doing your recording? I was interested in your recording of wrecks and working underwater. How do you control the accuracy in those circumstances?
Yeah, can you hear me?
Yes, sure. Higher.
It doesn't do too much for us underwater, but it's sorry, yeah. Yeah, no, we use it from a drone perspective, definitely, because ground control points, people think you can just fly across something and come back and the answer's immediately provided. But it's all about the quality control, the checks, linking it to whatever the coordinate control system is. And often we get challenged because people don't appreciate, that they mix resolution with accuracy, and sometimes there's existing data, sometimes data's merged. So you sometimes want to interrogate your point cloud data to find out which of the sensors or which of the flights or which of the surveys collected that data point. And that comes into play in the offshore side, where especially the surveys that are done with one eye on safety of navigation and safety of ships, if there's hazards in a shallow area, the general rule of thumb is that there's got to be a golden thread from that point that's collected all the way through to the point visualized or rendered on a map or chart, so that you can locate and you've got the provenance of that data point. That's something that's not maybe so commonly requested when you're doing the shambles or something like that. It's not really needed.
It will be in future though, Gordon, because now we've got the building regulations, and the new building regulator is now insisting on the golden thread. Part of that is to be able to do error tracing and also to control accuracy when you move data sets between different disciplines. So, we might be at this stage just thinking about the geospatial and the recording discipline, but then when you get into the other design disciplines, are those are those checks carried out at every level? And also, what we're particularly concerned about is the sort of systematic errors that go from project to project and survive all these layers of QA. Those are the ones that we really worry about.
Yeah, and I mean, I can think of a client who didn't really want the most accurate result. They wanted a result that they could fit and mesh with their existing data. So that it's not that you're trying to degrade your data, but you're trying to work with a client to find out what's suitable for them. And I think the idea that the data's got secondary or tertiary use beyond that initial sort of first project or first use by the client, that's not always something that's been recognised as well.
That's right. And the thing about the heritage community, the more you work with us, you'll realise that we're absolute hoarders. And actually, I was going to ask people a bit more about what their storage policies are, but maybe we'll do that in the next session. So that's a really cool image that you're sharing there, Chris. What's that? That's
so this kind of goes to, so this is a photogrammetry model of this church here. So there's approximately, I don't know, 5,000 to 6,000 images there'll be in this. So if we're quoting for a project and we know that we are delivering a quality product, you can see it's about getting, all the ups, all the downs, to show as much information from every angle, because that all goes into the accuracy of the model. If you can't, as a rule of thumb, if you can't see crisp data and lots of information, then you've got to start questioning the accuracy of it. And what you'll find is, like here, we're flying up and down, looking in every angle, and it takes time to collect the data, where what you'll find is a lot of people, especially the companies selling drones, and I know I'm harping on about drones here, but they say, oh, fly from 15 meters away with your Mavic Mini, and you'll be able to deliver that, and you can class it as a measure building survey and draw your elevations off it. But it's just not true, and it all comes, anything with accuracy, you have to get the specification right with the client. And whenever we get new clients, we spend quite a bit of time with them going over what they're trying to achieve, what accuracy do you want, what resolution do you want, because it all ties in. You need to work that out with the client first before you just do the job and hand it over, because you'll end up having to either redo the project, or the client won't understand. It'll go to, be delivered as a project on site, and just measurements won't be correct. Can
I ask you a similar question? I just put a share up now of some stuff by Matterport, because it's easy to say it when you're talking about drones and data collection externally.
Yeah.
But this one here is a sample that's up. I hope that's being shared now, isn't it? On the Matterport website. And if I click on this, you should be able to see that it's got these different viewing points. Now, this is probably quite normal for heritage sector. This is meant to give virtual tours to people. They're the sort of things you can use with a VR headset and what have you. But some of the detail and the accuracy looks good to me. Do you find that's possible for interiors as well?
With a Matterport, I wouldn't trust any measurements on it. They say that it is they've done a big thing with a lot of similar products, where they say that you can provide floor plans off it now and measure building surveys, but the quality of the actual scanners is pretty poor. And even the latest one, when we test it versus a proper laser scanner, you'll find a huge amount of drift. We use Matterport for certain clients, but it's only ever a visualization tool for just documenting a site visually. We'd say like there, you could run a measurement to find the width of that stone to the left.
Yeah.
You know, when it gives you a rough estimate, but I wouldn't trust the measurements for any.
So this is a question about viewers again, because one of the because Matterport's very accessible, so it's probably one of the I don't want to say it's low tech. Obviously, it's quite a high tech piece of kit. It's quite an expensive piece of kit. I think this Pro 3 is running at about £5,000 a piece, but obviously they're a lot cheaper than the kind of kit that you're using. So they're more accessible, but they're also lower tech in terms of the operator skill level, which makes them more accessible. And you can see all the geotags in there. You're explaining to a visitor through a sort of virtual tour what exists there. But one of the things that's really unique about Matterport, and I think it's slightly off-putting to me, is that the data never leaves Matterport, does it? It goes from their machine straight to
you
their
never you never own the data.
You never own the data. And that's, for us, well, two things follow from that. First of all, copyright. That's not how British copyright works. If I drive the camera, doesn't matter where that image gets processed, printed, published, I still own the intellectual property. That's a little bit worrying. But also because we sell these products to clients in a normal business environment where they're entitled to expect that, I find that makes me a bit uncomfortable about Matterport, because if we were to go back to them and say, look, sorry, we aren't able to sustain our license with Matterport, we've changed to another provider, and they go, oh, that's great, just move my model over. We go, no, sorry, can't do that, it's gone now. That's not the relationship we want to have with our clients, and it's not one that they should expect either. So I think it's worth sort of just pointing out to people who are in this session who aren't using these tech all the time that there will be issues over ownership, accuracy, and copyright that you need to look into as well as part of your, specification.
I think, like a simple pano tour, when our clients want a pano tour, we have a piece of software that we use, and we do it with a 360 camera. We export it. It's the client's property. They can have it on their own website, publish it wherever they want, and it's always their data. If they've got security concerns, they can make sure it's on a UK server, whatever you want. And there's so many options out there that, again, it comes down to specification, and that's a good thing to have in the specification is, where's my data hosted? Do I own the data? Do I have access to the data whenever I want it? Is there a time limit on when I can have the data? And if you're using a product like Matterport, there's a lot of questions there that you can't answer.
Well, I did have this is one of my 360 images, which is on Insta Studio. And I know you can join them up in terms of platforms on things like QPix and what have you.
Yeah.
It's an amazing tool for me as a building surveyor, because you haven't been there yet, Chris. None of the geospatial teams have been there yet. I'm just there on a safety inspection, just trying to work out how far you actually could get into the building if I did ask you to scan it. So you can see here that this is the pole. This is my 360 camera, and me safely stood in a doorway to drive it, and John, the structural engineer, taking slightly more risk to stand over here to see what the next story would look like. And obviously this is the point at which we looked up this staircase to what the floors are like above, and decided that was as far as we could safely go in terms of going into that building. So there's that very rough and ready sort of tour feeling, but you can contrast that very quickly with this one here, which is the Royal Naval College at Greenwich, where they've done this amazing virtual reality tour with 360 photography of the painted hall, and they host this on their website, and this is part of their visitor experience. And I think it's amazing because all these points here, you can click on them and get the actual tour, not just in sort of tags inside the model, but also with the audio as well. So if you're the sort of person who has mobility problems, or even the economic problem of getting to London and buying a £16 ticket for 4 children, this gives you a level of access that you couldn't possibly have by any other means. And it was funded by Heritage Lottery as part of the restoration project that was done there in 2019. You know, again, Eleanor's here, she'll tell you that you don't get funding in heritage, and particularly not from lottery, unless you can bring more and different people in to see your heritage. But it's by no means a geospatial model. It just doesn't, it's just not made from the same tech or for the same reasons that you and Gordon, the geospatial guys here, are doing.
Yeah.
It's part of the future though, because the two techs will merge, don't you think?
Yeah, 100%. You know, and within a laser scanner, you have it takes photos anyway, so it gives you that 360 pano deliverable anyway. You know, you just need to the quality of the image depends pretty much on the scanner that you're using. We have a scanner that we have digital SLR, so we can take the scanner off, put the SLR in the picture, and then you've got 12 61 megapixel images. So yeah, it's a higher resolution than any 360 camera, you know, almost like a gigapixel image. And then we export those and make 360 pano tours for our clients, because again, Liverpool Anglican Cathedral, during lockdown, you know, obviously no one could visit, so they lost all their funding revenue coming in from visitors. And they asked, what could we do with the data? We said, well, instantly we can make you a 360 pano tour, and you can, you know, we've got things in there where someone can light a candle, you can make a donation. There's hidden parts that they were charging to go up on the roof of the cathedral that we'd done. You know, it's a very powerful product, really, and a very, very cheap one to commission. You know, there's no, the cameras are cheap, it's very simple, you know,
it's more accessible than it's ever been. Did you, I was going to talk about VR headsets, because did you get that tour to run on VR headsets as well?
Yes, we did. And one thing, am I allowed to say this or not? Yeah, I think I am. So
I'll edit it out later for you, not.
Yeah. So we ran a cable from one end of the cathedral to the other, stuck a 360 camera on it.
Yeah.
And we're wanting to put a harness in one of the side rooms, put the VR headset on, you get in the harness, and you get like a VR zip wire experience from one side of the cathedral to the other. And I'm hoping we can do that for the summer. But we need, it's one thing we're going back to them, because it's just sat there waiting to be done. But we've just done, you might have seen on LinkedIn, we did a big thing at the Science Museum last week with the CAA and National Grid, and we used 360 cameras and VR headsets, and it was to get kids, and we did like a camera on one of the contractors' heads, climbing up a tower, going in a basket across, substation tours. It was just really simple to do, and
they're really good for these sort of training environments, because I know that in another life, when you're not doing heritage environments, you do training environments as well, don't you? And there's also, as well as the VR headsets, there's the augmented reality, whereby with the headset on and you're actually in the location, but you can see through things, for instance, like BIM layers and so on, so that you've got additional data that is popping up for you in the space that you're in. I'm going to just run a quick poll now, if I may. We're going to run a poll which is about VR headsets. I just want to get a little bit of feedback, please. How many of you who are here today have used a VR headset? And I've given you 3 choices. Yes, but only for gaming. Yes, in my work in heritage, or geospatial. I know we've got people from different backgrounds here. And just let us know if you haven't used one yet, in which case I think Chris will invite you around and you'll get a chance. Okay, so the results are pretty even, really. About half of us haven't actually done it yet. I think I tried them on once. It wasn't even for gaming, it was just to find out what they could do. And 14% of people are actually using them in their workplace at the moment. That'll be really interesting to see what that's like in sort of another 12 months or so.
I think just on the specification and accuracy, just if I can share the screen again and just go through one last thing, because I think it's quite a powerful thing. Right, Brill, can everyone see that? Yeah. So this is a Revit model here that was commissioned. And again, so this is all derived from laser scan data. So the point clouds are brought into Revit and everything's modeled around, but it's again down to the specification. So we have something when we are working with clients that shows the different levels of detail that generally what people want. So you have like a LOD 1, or sometimes known as LOD 100. So you can see like the level of detail compared to the different ones. So that's 1. That's 2. So can you see there's a bit more detail? 3, again, more detail. And I'll have to move that down.
It's like an architectural history tour in reverse.
Yeah. And 4. So you can see, if you look at the detail that versus that, this is, again, it goes down to the specification. The one that most people go for is LOD 3 Revit model. But then what you can do, we have a pick list that goes out to the client, so they can say, right, well, I want the roof LOD 1, I want this, the main bandstand LOD 3, and I need that detail there in LOD 4. And that goes down to everything from the most interesting one is like MEP in buildings and pipe work. But yeah, it's again, I seem to just repeat myself at the moment with specification, because that's the start of every project. And
it is, and I don't think you can fix it later. Is there any questions that I've missed in the chat? Anybody who wants to stick a hand up and ask anything else today? I'd also like to say thank you so much, Chris, for coming and sharing your models. That was amazing. And I will let you know if there are any questions that come up in the chat room after we've finished.
Yeah, do. Like I say, any questions, just ask away. I'm fairly open. But the accuracy one is in the industry at the moment. It's a bit of yeah, exactly. Yeah,
it's huge. Well, thanks everybody. Thank you so much for joining.